Hey guys, how's it going? Welcome to another episode of Ferris Makes Demos. Today's kind of funny because, well, oh man, my green screen is messed up. I'm gonna fix that, and while I do, I'll keep talking, or at least attempt to multitask here. Um, so this weekend has been a little funny for me because, first of all, uh, well, I actually don't know where to start. uh, let's see. So there are basically three things this weekend that I had lined up to happen. One of them is that I wanted to hang out with my brother and make some music online because we're doing this whole social distancing thing. And kind of a silver lining of that. Let's see here. I just need to make some adjustments to my stuff. Okay, that's better. Yeah, sort of silver lining of that is that my brother, who still lives in the States, of course, is normally in a very different time zone. So we don't really get to spend a lot of time together, but because now now we're both self-isolating, we can actually spend more time together, which is really nice. So we decided that this weekend we were going to start making some music together. And what ended up happening is that on Friday, when he planned to do it, he actually got the days wrong and ended up sleeping in too much and not waking up in time anyway. Which is kind of nice for me because on Thursday I didn't stream. I wasn't feeling too good. I was in a pretty bad mood for feeling like I wasn't really making progress on a lot of stuff. But I ended up sitting down and playing Doom and also working on some FPGA stuff anyway. And as it turns out, that actually went really well. And so I finally got the parts of the Xenoing that we still have bootstrapped, which is the CPU and all the memory buses and everything, working on the new FPGA board. So I'm excited to talk about that on the Thursday stream. And like I kind of had the breakthrough on Thursday and then had to do all the cleanup for all the extra testing that I was doing on Friday. So it kind of worked out that I ended up doing that evening. But then what happened is I ended up staying up really late because when my brother did wake up, we just kind of called and talked on the phone for a couple hours. It was really nice to kind of reconnect after a while. I hadn't really spoken with him very much since my wedding last year. But then what happened is I went to bed at like 4 or something, which is a much later than I normally stay up. So I woke up pretty late on Saturday, which is when I had planned to do most of the preparation for at least the outlining for my talk for Revision, which I don't think is announced anywhere yet. But I don't think it matters that I talk about it yet because, I don't think it's very important that I sort of spill the beans. I'm giving a talk on our 64K compressor. And because Revision is an online event this year, they want us to all record the talks, which I'm totally fine with. Like I have this set up, so it doesn't really matter if I was going to record it or stream it. And they're a bit concerned about like bandwidth issues, so we're gonna record it. But that means that I have to finish it not by the time I actually give the talk, but a week early. So I have to finish the recording next weekend, which means this weekend I had planned to spend more time on the outlining. But because I woke up so late on Saturday, and then me and my brother started making music only a couple hours after I woke up, so I did a bit more FPGA cleanup stuff in the little time that I had. Got that out of my head, got that out of the way, and then we started making music, and that ended up being kind of like most of my day yesterday, which was really fun. And now I was doing some cleanup, and I want to actually maybe continue that for a little while before I actually start working on some of the compression stuff. So if you guys don't mind, I'll probably do some production, which is something I haven't done on stream in a long time. So I think that's actually kind of cool. And I don't think my brother minds that I'm streaming this or the artist that sang on this track. We'll see how that goes. I think it's going to be cool. So I want to continue working on that just a little bit and clean some things up that's just to kind of get them out of my head. And then I want to actually start working on what I want to work on, which is actually like outlining the talk that I'm going to give at Revision in 2 weeks. Now, I only really want to spend this stream on that because I just kind of need to get out at least the outline of what the talk's going to be about, and then we'll probably dig through some compressor code to sort of guide that process. So I think that'll still be nice as a stream, but also I kind of need to use this time because because I've been so busy with everything else this weekend when I didn't think I would be. So I guess we'll just kind of start with that and just kind of hang out for a while. And I think it's going to be fun. So I guess a little words about some words about this track. This is a track that my brother's working on with an artist, and I actually don't know her name, which is kind of funny. And then he and I had sent some stuff back and forth, and when I had heard his kind of work in progress of the track, he was especially showing me a lot of the vocal processing that he did, which was really cool. And when I heard that, I just kind of immediately thought of like a lead kind of synth line. And I'll just play you guys some of this stuff, which I think is cool.
Stay with you, though I know it's clear you don't want me here, but I don't care. I know the truth, don't tell me who. Cause I don't care, not worth the work and overtime. Shouldn't cross the line, but I don't care. Can't hear the words they try to speak, not listening. Cause I don't care what you do.
This is super unfinished, by the way.
As long as I'm with you, yeah. I just don't care what you do.
So that's kind of what I have, and it's not like it's super unfinished, but I'm really kind of enjoying playing with this. And the synth line that I heard immediately when I heard these vocals is this part. If I turn off the sidechain on this, it's just... By the way, let me know, you guys, if the music's too loud while I'm talking. It looks like the levels are not ideal. In fact, I'll turn the music down a bit while I show this. That's probably... No, I can do better. Is that too quiet? Just let me know, you guys. Too quiet, you said? Okay, then I'll turn that back up. Appreciate it. Is that good, you guys? Cool. So the synth is not terribly difficult. I mean, I made it kind of on the spot as me and my brother were on Whereby last night. But I can turn off all this stuff here, and we can start with kind of the bass. It's of course a serum patch. I'll even turn off most of the stuff in here and the effects, because I kind of like how this is turning out. I think it's really cool. So this is the bass sound. So already, I mean, there's kind of some nice expression here. It's really just these notes, though, and what kind of works rhythmically. Like, there's no real, like, I don't do any play with automation, at least on the notes. Like, velocity play is not really something that I tend to do. But then that in itself is pretty much just a saw wave that has a bit of added harmonics. There's, I guess, crucially, there's this one envelope, which is pretty sharp. And that just adds some additional harmonics to add to the attack of the sound. But typically, I really like when these sawtooth kind of waves are pretty natural, where you just kind of get this really fuzzy top end with just a ton of harmonics. I always just like how that sounds on its own. So I like to start with that when making a lot of sounds. A lot of sounds kind of feature that basic stuff. Though that is a bit boring just on its own, and so I add the second oscillator, and this oscillator's turned way down, so you can't actually hear it, but it feeds into this oscillator to do FM synthesis. So it's a couple octaves higher, not even like detuned at all. Another thing to note is that I'm not using any unison or anything here, and that's actually for to make the sound keep its sort of mono shape. So I'll show you on the master if I put this into mono once I add everything back. There is a difference, of course, but it's not that high. Like the high end doesn't go away like it does if you start doing a lot of unison, because you end up with the sound kind of phasing itself out, especially at the higher frequencies. And it is actually important to think about this. Think about your signal integrity in mono, because otherwise you're gonna play this on a big system, and depending on where you are in the room, you're gonna hear different parts. Or parts of it will just be gone on certain speaker setups. So it's important to kind of get that right, especially like even on your phone. So it really pays off to kind of think about that here. And the nice part about a lot of these kind of sounds is you can do that. If you do everything in mono basically from the start and then add with effects later, it pretty much just works. So anyway, this just adds a little bit of FM, and mostly that is also with this envelope here. In fact, I think that's actually what this one's doing. Looks like there's another envelope that does the harmonics and even more FM. So this is a really sharp attack. And then this one just adds this. So I don't know if you can really hear the difference here, but we'll see. So it's really just on the attack of the notes, it kind of turns up. If I turn this up like a lot, it gets kind of crazy. But the point was, again, just to make this a little bit cooler on the attack. And also to embellish the attack even more, I add a noise layer. So if I mute everything and just play the noise layer. It is in there. You can't really hear it. Maybe if I add like the saturation, you can. Yeah, it's a little bit in there. It's subtle, but it does actually add some stuff here, which is nice. You can hear when I add these things, it really kind of breaks up the sound, so you really get a lot of that attack. Additionally, I add a sub, which just goes straight out of this and bypasses all the filters and everything. And really that more just embellishes the low end, because this sound already has a lot of low end in it because it's at a pretty low octave. The next thing I do is I add this filter, and this is really what brings out most of the sound. It's a fairly resonant low pass. And here, this also is on this same attack. And that's what's giving it most of the sound. And then also I automate a bit with this macro here, how open that filter is. So you can see here at the end of this phrase. And all that's really happening there is this filter's literally opening up, like the frequency is just getting higher on that. So I think that's pretty cool. Now it still sounds a bit empty because there's no effects. So then I add some of this hyper stuff, and this is just to add a little bit of stereo width. If I pull up Ozone, we should be able to see that. This is a plugin on the master, and I think this imager should show it. I actually do some processing on the master. I normally don't, because I like to fix this on the sound level, but since this song will not have very many sounds, it kind of just made sense to just fix it here for kind of a workflow optimization kind of thing. So without it, you can see that there's no width in the sound. And if I turn it on, you get a bit. It's not much, but it definitely adds some dimension. And again, if I hit mono here, now I can kind of A/B check. This is what it'll sound like if it's summed to mono, and this is what it'll sound like otherwise. And you can't really hear a difference, and that's kind of what you're going for with a lot of this stuff. You will hear a difference as I add more stuff. So then there's this filter. You can see this adds a lot of the bite. And one of the things I do here is I also take this sharp envelope here and basically only mix it in. And same with the stereo width, I mix it in with this envelope. And that way you get this nice wide attack, but you still maintain the integrity in mono. So if I turn this way up, it sounds a bit more springy, but it also sounds like it's kind of phasing out. And so it's not as clean. So that's why I only enable it sometimes. And I like to play with these combs, and especially some of the weirder ones in here, like this reverb or all pass or whatever. But this is the one that worked for this sound. The next one is actually, I think, where most of the beef comes from, and this is a multiband compression unit. And it does both upwards and downwards compression. I take especially the top end and kind of boost that with this. So it kind of squashes the dynamic range in 3 different frequency bands. And then it also pushes the upper one up a bit, and that's what's just going to make this a lot brighter. So that's where like so much of the presence just comes out. And if I go back and start turning stuff off again, now you really hear the noise. That's pretty cool. And then there's a bit of a delay here in reverb, and I think these are normally turned down pretty low. But there's this Moar reverb knob that's similar to the open knob that also increases these. And normally the feedback's pretty low and the mix is pretty low, so this just adds a little bit of like sparkle. It's more of like a short plate reverb could also do the same kind of things. You can see the left and right are not BPM synced, and they're both pretty small, but they're also both different, so we get a bit more width from this too. But mostly the reverb and then turning this delay up is used for this effect at the end of the phrase. See, I play with the reverb in the middle there too. I think it's cool. In fact, I think this is a mistake that this automation's like this. I think I meant to do something like this. I'll probably do something like that actually. Yeah, I love these scopes in Ozone. So if I take this in, we'll compare stereo and mono. Not much difference, which is kind of what you want. It does feel fuller with stereo because there's more information there. But mono, it needs to sound clean here too. So it sounds right to me at least. And then in addition to that, there's a bit of saturation, which again just kind of makes it louder. And there's some EQ, which just boosts some sort of key frequencies and ducks some others. Not a lot happening here. And then I add this, which is mainly just adding this reverb. So if I don't have the reverb, it's a post reverb. So this is what the reverb sounds like on its own. And this is literally just to put this in a space. I don't think this one's ever modulated. This is on top of the reverb and delay in the synth. And this also has a filter before the reverb, mostly to cut the low end, so that it doesn't ruin anything down there. In fact, I might even tighten this one up. But then the sound just gets kind of huge with everything. But again, we're good in mono, so. And there's not much happening during the rest of this part of the song, which is kind of intentional. So. Oops, I forgot the sidechain is actually critically important for this song. And for sidechain, I'm not actually using real sidechain. This is just an envelope follower that I trigger with some MIDI that matches the kick. So there's the kick and then a MIDI trigger here. And then this will follow this very particular envelope. And again, I do this for like just very specific control because it can be hard to do this with actual sidechain. This is a device that we really need to add to Wavesaber. Then you get the pumping feel already. So lots of stuff that I'm kind of playing around with here. I guess there wasn't really much more I wanted to share with this today. But there was actually one thing I wanted to fix kind of mix-wise. And I don't know if you guys can really hear this, but it really bugs me when I see it on the scope. And the main thing is with this kind of synth, at least the way that it's being played here, we jump around between 3 different octaves at least. Yeah, almost 3 octaves. 2, 1, 2, 3. And almost get up to the 4th one. Thanks for the sub, Finrog and a Ferris. Yeah, I read it the first time. I didn't want to point it out. By the way, hi to guys in the chat. Zokwar, Finrog, Dark Second, Philly Delsky, Justice or Eustace, W Writer, Aaron the German. What's going on, guys? But yeah, this synth, when it does that, and this synth also has like a really heavy sort of sub bass. So let me pull up the scope. This is sort of the whole frequency spectrum. And sort of down here, this is where we actually want the sub to be. Anywhere from 200 to maybe 150 or so. Like that's a bit high. Aaron the German, this is unreleased. This is something I'm working on. So you can't listen to the full song yet. This is just something I was working on with my brother. And I'm still working on it, even though I should be doing other stuff right now. But when the sub kind of goes around here, if it goes a bit high, I'm okay with that, especially with this kind of composition. What I don't like though is when it goes up to like 200, and you can see these huge spikes here. Like this stuff. And we got to be a bit careful there. Luckily, I bought a plugin today that's really good at helping with this kind of thing. I don't know. I think it's going to be released. I mean, my brother's handling all those details. This is a remix that I'm doing for him, working with an artist that he's working with. So I don't know where it's going to be released, but I'll definitely tweet about it and stuff when it's done. This just kind of really organically happened as of yesterday, so I don't really know yet. All this work I did yesterday. Except my brother did all of the vocal processing and the original track, which is also not released as far as I know. I think they were talking about releasing that track and then this remix at the same time as kind of a single package. Anyway, so this is Waves F6, and this is really nice. This is a dynamic EQ. No, my brother's not the vocal. He did all the production, but it's this girl called Blair Woods, I think is who does it. And the idea here is that like a normal EQ, you can sort of boost or lower different frequencies. And, but in addition to doing that, like you would with a regular EQ, whoops, that's not what I want to do. It's the gain I want to turn down. In addition to that, you can also have these be processed dynamically. So like if I isolate a certain frequency, so if I solo this, I think actually we're going to want it like here, and we're going to want to widen the range that this covers. In particular, it's this stuff around like 250 to 300 that I want to sort of squelch a bit. So that's kind of what that band sounds like. But when it goes really high up here, I want to sort of cut those down, but I only want to duck when it goes that high. So what I'm going to do is I'm going to turn the threshold down a bit, and I'm going to probably overdo this when I first do this because I'm not that used to using this plugin. But the idea is that this threshold, this is when this compression will kick in. And then I want to turn this range down. Or is that what I want to turn down? Because we should see this ducking. That's just if I normally duck it, which we don't want because we want this to be dynamic. I totally don't know how to use this. This is funny. Oh, there it goes. It only ducks when I don't have it solo. or at least shows that. That's what I want to see. You can see it just dips only when there's those really high notes in volume. Duckers is not an Outtracks reference. At least not directly. This is the Duck Bus. I usually call those Duck Boys, Ducky Boys, Duckers, Duxors, all kinds of stuff. So now these peaks up here are a bit more under control. Yeah, the clicking is let's see. There's a couple things doing that. You don't hear it when there's normally the track. When it's on its own, I think it's actually the sidechain that's doing that. So I think it's whenever the kick hits, this basically just ducks immediately because I have like no attack on this envelope. And that's actually intentional because, again, when there's the kick there, you don't hear that. I think, too, when this opens up at the end here, I can also hear some harsh stuff here, which I'm guessing is around 3K. We'll probably try to isolate that and make it worse first. That's higher. Yeah, it's around that like 8K. So I'll reset this one, I guess. Or I'll just use this, doesn't really matter. But for this as well, I want to also do a similar kind of treatment so that when this gets louder, I want to bring it down. I think that sounds a bit better. And the other thing is that I have a couple versions of the synth because I normally do this where I'll just like take a synth and then duplicate it a few times. And it's kind of annoying when I do these kind of mix fixes on top of those, but the nice thing is that I can tweak these individually for different parts of the track. Thanks, Aaron. Appreciate it. Hey, Anna Moran. So I totally don't have this build up made up, so you guys are gonna have to imagine a lot of it. But actually, this also needs to.
I just don't work the work and overtime. Shouldn't cross the line, but I don't care. Can't hear the words they try to speak, not listening, 'cause I don't care what you do. Just as long as I'm with you. Just don't care what you do. Yeah, just as long as I'm close to you. Yeah.
Try some things here. Probably don't want this here, but we'll try. That's actually cool there. Yeah, it doesn't sound like anyone's brother. That's great. Let's see. So for this, I have this little thing here. If you guys have ever heard that Talking Body song by I'm gonna say Tove Lo, but that's not at all how you say that. It's a Swedish name. Anyway, I really like that track. And it has this like crowd sample in the beginning with these offbeats, and I'm totally ripping off that idea here with this sound. Let me play this out for the sidechain to reset, and then here. And what I'm doing now is I'm kind of adding this at the beginning of the drop too. So somewhat subtle, but the thing is I want this to kind of fade in before it hits too. So I'm going to take the sound here and I'm just going to re-render it such that it covers the whole thing here. So I can put it here and reverse it. And then what I'm going to do is I'm going to stick a reverb on this. So we kind of get a reverb on the tail of like the start of the sound, and then I'm going to reverse it again such that that fades in. And then that's going to fade in nicely to the actual one, but also be a bit quieter and a bit sort of farther away. So we're still going to be able to get impact when this actually hits, but this is going to sound, it's going to kind of dampen it before. I think I'm actually going to do the tests with this part here. So I'll listen to this on its own. And I don't know why we didn't hear that. Oh yeah, that's why, because the... like that. And so we're going to stick a reverb on this. Anyone will do, basically. We'll stick room on this, get a nice fat one. I want bigger. That's way too long. Ugly Tattoo, thanks for the follow. I want something darker. Is there like a... It's down, turn the high cut down, I think. It's this we actually want to adjust. Good. And we want a little more tail than we'll actually use because I'll shorten it with proper fades. So we do that, and then we can flatten this. And now we just have straight up audio of this fade in thing here. If I just consolidate this, we never need it that long. If I consolidate this, then we just have the sample here, and I can basically normalize it by hand. So now this is the tail. Sounds pretty cool. So I'll reverse this, stick it in here, and we're gonna make that basically way shorter. Something like this. So if I play these together, like that, you can see this is a bit darker because of resonating frequencies, but that I think is gonna be fine. Just turn it down. Now they fit kind of nicely together. I will stick an EQ on this though, because it is still a bit too dark. Yeah, I think that sounds really nice. Now all this is supposed to be subtle. I don't even know if like, I don't even know how audible it was, but. In fact, I actually do want to turn those up there more. So we'll do... Again, I'm duplicating this because the one in the intro needs to not be as loud. And so with this, we can turn this up a bit. I think the way I want to do this, because I think the peaks of this are already not quite normalized, but fairly high. So I think I want to... compress that instead. I'll just use the typical compressor here. And the nice thing is this normally has makeup on by default, so yeah, for if I were to use this for a demo, this would just be straight up MP3 render. That's quite a bit louder if I just do that. I'll do the same with this one, which will make the fades have pretty different dynamics, but I think it'll sound good. Yeah, we didn't hear it because of the sidechain. So there's a lot more that needs to be done with this, but those were the things that bugged me most today. So I think I'm going to put this away for now. But thanks, guys, for indulging me while I work on this a bit. Appreciate it. And I'm glad you hopefully liked what you heard. I have no idea when that track's going to be released or done, but I think I'm going to keep it fairly minimal and just mainly work on like a nice build and sort of one sort of arc where it goes up and down. The original song has a couple different verses and a bridge and everything, and I'm just not going to have that for this remix. Thanks, W Writer. I always love that trick. And especially in a lot of modern music, it's used a lot. So anyway, time to actually get to work on the compressor talk. So when I signed up to do the talk, I knew that I wanted to talk about our 64K packer, which is called Squishy. Now, I haven't actually released it, built a proper release, and I kind of wanted to do that before I gave a talk on it, but I think I have to kind of get an outline of the talk before I actually spend time on releasing it. And it's basically ready to be released, except for figuring out the right kind of license. And what I mean by that is that it gets a bit complicated when you want to license something like a packer, because you at least need some terms about, how should I say it? First of all, packers are used in malware a lot. So I know a license doesn't fix that, but at least it's like we took a stance on it that I don't want this to be used for malware. So I'm going to do a more restrictive license than a lot of other tools that I make normally have, because normally it's like Apache 2 or BSD or MIT or something. But this I actually want to be a little more restrictive in order to make it clear that that's what this was designed for and what it's meant to be used for. And the other thing is that because it generates some code, or it packs some code with your executable, mainly the decompressor stuff, we need to have a license for that essentially transfers ownership of that data to the user. Now, Crinkler has a license that basically does exactly that. So I'm pretty much just going to rip that off, I think, which I think is the right choice for that kind of thing. So that's kind of the last thing that I really need to fix before I release it. There are a couple other issues. In fact, let me pull up the size comparison stuff that I have. So I have this spreadsheet where I maintain all of the stats for Squishy's performance. And I think I've shared this publicly now. I can link you guys anyway. Because I don't really care that it's public anymore. And the main thing here is that we can see, if we just look at the graphs, I think that's the easiest thing to see. There are several different, get out of there. There's several different bars here. So these on the left here, these are a bunch of different executables. Philadelphia says, super question. Why not just put the code out without a license? Because then people can actually hold you accountable if they break stuff with your code. And so you need to at least have a license. Actually, there's two things, because that's the liability side of it, right? That people can launch a missile with your code and claim it's your fault if you say that. Yeah, or if you say that, like, let's say I put out an executable compressor and it doesn't actually compress some executable, and then someone loses their job over that. I mean, it's completely ridiculous that would happen, but if that happened, I could actually be held liable because my software didn't meet fitness for a particular purpose. And so you need to have like clauses in a license that say that. The other thing is that the way intellectual property works, at least in the United States, but I think most of the Western world follows a similar philosophy, is that as soon as you like write code, that is your intellectual property. And so you don't actually distribute software, you license software. So in order for anyone to legally be able to use that and copy it and distribute it, they actually need license terms from you, who is, by creating it, you are actually the owner of all the rights to the software. And so you want to be able to relinquish some of those rights to some users. So that's also why you do a license. So it's sort of those two parts. It's liability and you want people to actually be able to legally use it. So now I'm not a lawyer. I should have said that before. So my understanding of that is that's about my level of understanding. I don't really understand it much deeper than that. But I know you need a license for this kind of thing, so we're going to do that. And the other thing that I wanted to talk about, so first, if we look at these graphs, on the left, this is just a corpus of a bunch of intros. And whenever I add new ones, then I'll add them here, and you can see like this is the original file size in bytes. You can see the final size in Squishy, and I've also color-coded these. So green means Squishy wins. Yellow means that against the latest Crunchy, it's the same size, and red means it's worse. And so this is the final executable size for Squishy, and of course these are all rounded to 512 byte boundaries, and same with Crunchy. And then you can see the difference, and that's why these are all always going to be multiples of 512 bytes. So you can see, again, green means we won, and this is the margin. You can see, like, for example, in Gauge or Trash Panda, we win by quite a large margin, which is really nice. Dope on Wax as well. But there's a few that are exactly the same, including Vessel, which I've had particular trouble with. And then there's one where it's worse. And let's see. Yeah, and then this is the final section size. So this is without headers and everything. You can see Squishy actually wins across the board. But Squishy, in order to get these wins, has to pay a little bit more for the headers and the decompressor, which is a bit bigger. So that's why in the end, sometimes it doesn't work out. And then there's a diff of the section size. And this is in actual bytes, not rounded. So this is kind of This is usually the metric that I'm mostly looking at when actually making tweaks, but then this is the one, of course, that matters in the end. And then you can see also there's this time in which it took to compress. And I by the way, I enter all this by hand. It's not that tedious when you only do a couple intros at a time. And you can see here I've also color-coded it. I don't remember the exact rules here. So if I find it, conditional formatting. Yeah, so I decided that there's a certain time envelope that I want Squishy to operate in. And it's basically 8 seconds is kind of the max that you want to wait. So this actually takes in, this is the time from when you double click the executable until you even get a dialog, until the user's code actually runs. So this is basically decompression time. And you can see it gets pretty close to 8 on there. And by the way, 8's kind of an arbitrary number. I literally took that from one of Rig's posts on Crunchy where he said that back in 2007, when they released Debris, it was about 8 seconds. And that was like the threshold of pain on his Pentium 4 at the time. So this is on my machine on this i7. So there's faster processors out now. But I decided to say, like, okay, let's have the same time envelope. And then because we have more CPU and memory, we should be able to do more compression within that same time. So it's like the same user experience that you would give someone using that Packer in 2007, but now you get better compression within the same envelope. So that's what I base this on. And you can see anywhere from 5 to 8 is kind of the high end of that. And so those are these yellow ones. Anywhere above 8 is this red one. Yeah, it probably has to do with that as well, Aaron. I wouldn't be surprised. And then green, of course, is below 5 seconds, which is basically always acceptable. And you can see Crunchy is a lot faster than that in most cases. And again, that's because it's older. So it used to be these kind of numbers, except this one's an outlier. So it used to be these kind of numbers when it was still being actively developed. And now, because of the passage of time and the more CPU cycles and memory and everything, now it gets obviously much better numbers. So that said, like if you wanted to compare Crunchy and Squishy, which right now you can't do because Squishy isn't released, but when that's the case, you actually might want to take this into account, because if you end up in a case where you get the same compression, for example, then it would actually make more sense to use Crunchy. And those are cases that I'm not going to care about. Like, the goal of this is to make our intros compress better, and also because I like to make all the tools ourselves all the way down, which is one of the reasons I'm doing 64Ks in the first place. So I don't really care which one you use, but what I did care about is being able to use that time effectively. So in most cases we win, but in some cases we don't, and in the cases we don't, because compression is both a speed and size trade-off, you'd be making a better decision if you use Crunchy because of this. So that's something to be said. Also in these notes, you can see this is the version. I've labeled this as 0.1.0 because that's what the release version is going to be. And then you can see when I last updated this. You can also see there's some notes. So for example, I have one intro here that just crashes. I don't know why. This is actually Gubernia. I don't know why this crashes with Crunchy. I think this works with Squishy though. No, it says Squishy's output executable also crashes. So I'm not entirely sure why that is. But this is one I actually did want to talk about. This is Felix. I think it's called Felix's Workshop by Control-Alt-Test. By the way, if you guys are making 64Ks, please send me intros that are uncompressed, because I like to expand this corpus. And ideally, this should benefit you, because that means I'm tweaking the algorithms against your intro along with all the others. So I really want that stuff. Anyway, this one actually crashes after the loading bar, and I actually figured out why this was. And this is due to one of the code transforms that Squishy performs. And in figuring out a way to fix that, I actually found something that also benefited compression that won like 500 bytes on all intros, which is pretty sick. But I haven't implemented that yet, and I don't think it'll make it into the first release version, but it would make it into like the second, for example. So, and yeah, so I think generally we do pretty well. It's a good Packer. Couple where it doesn't quite work out, and I think only one where it's actually worse. So pretty good. And there's a lot of other things too. Like I know that we could get a lot of, like, one of the reasons I designed Squishy as a purely executable compressor versus something like a linker, which is what Crinkler does, is to get an apples to apples comparison with the state of the art, which is these pure executable compressors like Crunchy. And I think that was a good choice. But now I think it's at a point where, since I know that an apples to apples comparison wins, we can start looking into things that are like, how can we get additional benefit? I'm sorry guys about Slack. I'm gonna turn off my audio. We can start looking into things that's like, how do we take this a step further? Oops, sorry. Yeah, exactly. Two curves. Sorry, I got distracted there because Hoffman sent me something, which I'll have to look at later. Anyway, yeah, I wanted an apples to apples comparison with current state of the art, and now that it's winning, I think we can, or I mean, I say winning, but it's like it's better within the same time envelope. I think we can start looking at other things in addition to this. So, for example, we could look at having a linker mode as well, which I think would be nice. Another thing I would like to look at is 64-bit. So it'd be kind of cool to build our intros as 64-bit executables and then try to compress them there. And I think if we ever look into Vulkan or something, we're kind of going to need to do that. As far as I know, there's some of those libraries that are 64-bit only, so we'll see. Yeah, I guess there isn't much more to say here. But yeah. So in coming up with this talk, I'm actually kind of curious if you guys have any specific questions that I could kind of try to answer with that, because it's a bit difficult. Like, I know I'm going to have an hour to talk about this stuff, and I kind of signed up for this thinking that, like, I love talking about compression, so let's just do that and see what I can fit in there. But when I thought about it, there's actually a ton of stuff, and I should have known this because I have a ton of unfinished blog posts about it that go into a lot of detail, and I don't have anywhere near the kind of time it would take to go into that great of detail. So what I was thinking, you guys can let me know if you think this is a good idea, is I was thinking to do, actually, I'm just going to open up some notes here. It's kind of like a compression 101, because there's a lot of, like Two Curve says, no idea how an executable compressor works. And I think most people are in that boat because there aren't a lot of people making executable compressors. So I think what I want to do actually first is super quick. So like lightning intro to 64Ks. 64K would need more work for linker, but I actually don't think so. And actually, there's another reason I might want to do that, which is I think Rust might move away from using the existing platform linkers at some point. And if that's the case, then we need to be able to probably supply our own linker to do this anyway. The other thing, yeah, I should zoom in. Thanks. Whoops. Actually, I want to do it here, like this. But actually, another thing to point out about linkers is that we actually already have some linker functionality in the existing packer, which we have to have because like we have to link all of the stuff for the decompressor stubs. So for example, there's this stage 1 sort of entry point thing, and this is the main stub, and this needs to know where stage 2 decompress is going to be. So we need to know where all the data for the other stages is going to be in memory to link this in with the existing code. So there's a lot of stuff like that. So we need to have some linker functionality to link this with the existing stuff, is my point. So we already have a lot of that functionality. Why not go full linker on this, which might actually make some sense. But that's also one of the reasons why Squishy operates as a 32-bit executables again is to get this kind of apples to apples comparison. But yeah, I was thinking to do like a lightning intro to 64K intros. So like, what are we doing? And then I also want to have like kind of maybe a flow chart for assets and whatever. Just again to show the compressor at the end. And also maybe some sizes before we do all these processing steps, because like in our case, for example, we have the music data, we have shader data, all that kind of stuff, and it all gets kind of pushed into this one data blob, actually two data blobs, because there's the compressor stuff, or there's the music stuff, and then there's the rest of the intro. And then all that goes into an executable that's like 300K or so. In fact, I have stats for that. It's anywhere from, like in this case, this lower end is around 100K. Just below 100K is the like lowest, and then some of these larger ones are, in this case, 400K. And again, this outlier, which is one of the reasons why this takes so long for this conspiracy vessel one, this is 1.6 megs, which is way higher than most of these. Like our intros, I think average out around 300 something K, 400K. It looks like the top end for like dope on wax. Now this size, again, it doesn't really matter, because what matters is the output size, is how well this compresses. And if you have like a large thing here that compresses really well, then that's fine. But uncompressed size does actually matter, because that means your decompressor is processing more data. It literally needs to output more bits and predict more bits. So this is kind of the bounding factor for time. So this compressor is kind of useless for conspiracies demos. It seems to be that they've claimed that it's the music file or the music format that is so big, and I haven't looked into it to verify, so I'll just take that for granted. But yeah, so it ends up being like 400K usually, and then that's compressed down to 64K or so. And in fact, on Dope on Wax, we wouldn't have fit if we didn't have this compressor. Probably could have started optimizing things more, but it's nicer to not have to. So then I was thinking to do like a lightning intro like this, and then again, then you see like what the compressor is actually doing. It's taking that larger executable that's produced by sort of normal means, and then doing a bunch of magic on it. And then it might even make sense to kind of transition from that into like executable compression, because there's things like what's in an executable and like what kind of processing do we do. Processing, slicing, moving stuff around before we even get to the compression stuff. And then I was thinking to do like squishy decompression unpacking flow, because squishy actually has two compressors in it. There's what did I call them? There's the stage 2 compressor, and this one's the big one. It's model. It's where a lot of stuff is. And that's the big one. That's the one that's doing really the heavy lifting in this compressor, and like the x86 modeling and everything. But in addition to that, because that model and everything is so large, we actually have a second compressor stage that runs before that just compresses that decompressor. And that's a much simpler compressor. This is basic LZ stuff with an arithmetic coding backend. So I kind of want to outline that there is that flow, and that there's some differences there. But then I want to actually focus on the stage 2 decompressor, really. A co-charter said, don't know how many would care, but basically would love if the talk addressed what steps we need to be taken to compress binaries on Mac OS X and Linux. Yeah, I think that's going to be outside of the scope of this talk. I mean, again, with executable compression, like this stuff is all general, but then, and also the compression stuff. So I guess it's going to be relevant in that way, but I won't talk about other platforms, mostly because I don't have that much experience with doing this thing on other platforms. But I think all this stuff should carry over. Like you'll get a different kind of executable format, but for the most part, like this same compressor should work in both contexts. So I think mostly the packaging would be different, but eventually if I release Squishy as open source, then I would hope someone else would pick that up. Yeah, Squishy's Windows only. The compressor, of course, runs on any platform, but it only produces Windows executables, and it only operates on Windows executables. So that's a restriction there. I probably would have been interested in Mac at some point, because originally our tooling also worked on Mac, because I was on a Mac myself a lot more often then, but we dropped that support in order to use compute shaders anyway. So yeah. And now that they won't get Vulkan support probably ever. I mean, they do via, was it Molten VK, which is the metal compatibility layer. But still, it's not something I want to bother with. Linux is, I guess, more interesting, but a more niche audience. So I'm not that directly interested myself, to be honest. But at least all of the compression stuff I'm going to talk about is pretty general. So, and then this is where stuff gets really interesting, because the compression is like an executable has a high dynamic range. Yeah, that's great. So I think I want to start with some theory here, because Shannon entropy, symbol alphabets, etc., all that good stuff, because I think it's like there's several different kind of families of compression algorithms, like the LZ family, which is used in this stage 1 decompressor, or the more statistical context mixing family, which is used in the stage 2 one. And I guess actually the stage 1 is a bit of a mix, because it's LZ with statistical coding backend. So anyway, I want to go into a lot of theory and kind of guide the user, like the audience, to see, like, from a compression standpoint, Squishy's actually really, or I guess most of the compressors that are actually pulling the most weight in terms of compression performance are pretty theoretically simple, and the sort of classical models that we have are actually the most relevant ones. Whereas a lot of other compressors that are more balanced towards speed, because we're working with comparatively very little data, those will do things like mixing streams or update model frequencies a lot less often, whereas we do that after every symbol. So our sort of inner coding loop looks how you'd want it to look if you were just learning this stuff, actually. And again, that's because it gives the best performance. So I want to start with some theory there and talk about that, and in particular, coder versus model. And the idea is that model is sort of a statistical representation of the informational content of the thing you're compressing. And then the coder is the thing that, given frequencies and some symbols, it will encode things, or given some frequencies and a stream, it will decode symbols, and then you can update the model and stuff. Here we can do like static versus adaptive. Coder families. Let's see. I always forget what they're called, but Huffman is a subset of a family of coders called something else. And it might just even be fixed width codes. Or, no, what is it? Is it something prefix codes? Yeah, it's actually an optimal prefix code. Yeah, that's what it is. It's prefix code is what it is. Prefix free code is also it's called, which I think is what I was thinking about. But yeah, I want to go into some theory, and then I want to get into this like coder versus model, because you find that like the coder and the model are very separable things, and the coder is kind of a solved problem if you have enough bits in your target processor to do this kind of coding at high enough precision, which we do even in like 32 bits. In fact, I think we even use like 12-bit probabilities in Squishy, which I would like to explore that a bit more at some point. But anyway, then main focus will be on modeling, since coding is basically solved. With a note there to mention that ANS is fairly new, but mostly its benefits are not things that we can really take advantage of here. And in fact, I actually played with ANS versus some arithmetic coding in Squishy several times, but ended up being able to build a smaller arithmetic coder which had negligible differences in precision versus ANS. ANS has a lot of cool properties. One of them is that since the data stream is always in sync from the decoder and the encoder, which isn't the case with an arithmetic coder because there's some like carry propagation and stuff. But because the ANS one is always in sync, you can do things like mix streams a lot easier. And you can use that to actually get a bunch of streams decoded in parallel. But you can only do that if the model is able to feed the decoder with all the modeling information you need to code those different parallel streams. And since we're doing probability updates after every symbol, then our modeling update becomes the bottleneck anyway. And so even if we had more streams, it would just end up being more code, and it would still be just as slow because the model updates are memory bandwidth bound anyway. So we're pretty screwed in terms of trying to take advantage of that stuff, which is kind of nice, because that just means we don't really have to. We can get a simpler model and make it work more effectively. Squishy again has two. Just to answer Yannimaran's question, is Squishy LZ77 plus entropy coding? No. There's two decompressor stages. I might as well just start making some of these diagrams now. Now that there's actual questions. Let's not do that right now. Actually, I don't know how I'm going to make this diagram look, but there's actually two decompressor stages. And the first stage decompresses the main decompressor, and then the second stage is the main decompressor that decompresses the intro. And so that first stage is basically LZ with entropy coding as a backend. And the second stage is not LZ at all. It's just pure entropy coding. No, that's okay, Yannimaran. I appreciate the questions, and I'm happy to answer. I know it's confusing, and that's one of the reasons why I want to give the talk too. So this first stage is probably the less interesting one, but it does have some cool stuff. So like one of the things I did here is I actually biased the initial predictions so that they're not all, it's an adaptive model, and I biased the predictions such that it's, I think, a little bit closer to 0 than to 1. And I actually did brute force search on some of these parameters, like how many bits I could use for predictions, the learning rate for the models, and what the initial prediction values were. And I found that for this particular decompressor stub that I'm compressing, which is the only data that this first stage compressor actually works with, these were actually optimal parameters for that data. And this is the kind of thing you can do if you know you're compressing the same data every time, whereas the next stage has to be a lot more general purpose, because that's what's actually compressing the user data. So it's kind of cool to explore a lot of that. But other than that, it's a pretty standard, very basic LZ. There's also some interesting stuff about the parser, like the actual compressor of that, because again, with these things, because we need to make the decompressor very small, it has to be relatively simple. But that doesn't limit our coder complexity at all. And when you do, especially like LZ, you can make a really simple decompressor where a good compressor is going to be really hard to make, and especially really hard to make fast. Because you essentially end up with a lot of different ways to encode the same piece of data, and then coding becomes a search problem where you have to find one that will sort of optimally use all of the different coding possibilities the best way. And that can be really hard, but there's some good algorithms for that. And especially if the amount of data that you're coding is fairly small, like it is here, it's only a couple kilobytes that we're coding, then it's you can do that really well. So I think there's some fun stuff there, which I won't end up talking about because I think I want to again talk about the stage 2 one. So yeah, so then there's this coder versus model, and then it's about modeling. And for modeling, like our task, as outlined in the previous section, is to predict bits. And one of the really fun things about when you start talking about these bit predictors is there's another place, like obviously these are used in compression. But they're also used in, for example, branch predictors, because a branch predictor in your CPU has exactly this job. If you think of whether or not a branch should be taken as a 0 or a 1, 0 is not taken and 1 is taken, then it has exactly the same job. And the really fun thing about that is if you look at like branch predictor on Wikipedia, they start talking about things like, let's see, there's static branch prediction, which would be a static model, dynamic branch prediction, which would be a dynamic model. And you have like 1-level branch prediction, and then you start having these models, and these directly correspond to some models that we use in compression. So if there's this awesome resource called Data Compression Explained by Matt Mahoney, and I'll link this to you guys here. And this again goes into modeling, and let's see. I know this goes into these predictors, but I don't remember where. It's been a long time since I looked at this document. But yeah, that's what it's called. Direct models. You have these direct models and indirect models. And that's exactly these. 1 level is a direct model, and a 2-level predictor with this pattern history is an indirect model. Like, they're exactly the same. Same ideas. Then hybrid predictor with these combined predictors. This is actually what we're doing with context mixing. So that's kind of fun. And then let's see. These neural branch predictors is also what we're doing with how we implement the mixer. So that's pretty cool. So yeah, there is some machine learning in here, but it's not, at least I don't understand as much of the theoretical heavy stuff as I would like to. Hey, Rimina. So we'll get to some of that, but that's definitely what I want to talk about is how some of these work. So I want to talk about like direct models, indirect models, because I think these on their own is pretty easy to understand. I know what you mean, Aaron the German. I hope this talk will clear that up. Because a lot of this stuff took me a long time to understand, and I've read, for example, this document I've read so many times, and also like Charles Bloom's blog, and Riggs' blog as well has some really good stuff. I want to talk about cache tables at some point in here. But this is more model implementation. Yeah, because I also have to talk about context versus models. Yeah, there is actually ML in here. It's not as, like, there's a lot of research papers now about using ML, like more, I guess, more modern ML, you would say. And how do we say this? That's great, W Writer. Sorry, I'm getting a little distracted. Where was I going? Oh yeah, so like more modern ML where you're doing like deep learning, for example. There's a lot of research in using recurrent neural nets for this stuff, which which again, you build a model out of a recurrent net. And a recurrent net is just a net that has states. These like direct models and indirect models, you could categorize those as recurrent neurons. But I think at least the architectures for those models that I've seen seem to not work very well. I know that the mixer strategy that we use can be classified as a gated linear feed-forward neural network. But to be honest, I don't really have a lot of the knowledge to explain it from that perspective. I have a much more mechanical understanding of kind of building up these simple things rather than a strong theoretical understanding from the machine learning perspective. But anyway, at least when I was testing a lot of those things that kind of came along with a lot of those papers, they seem to perform quite a lot worse than these special purpose ones. And I don't really know why. I don't really know how to analyze that and kind of compare them in a meaningful way. So I don't really know why they perform worse. But they do. But that said, the model mixing strategy that we're doing is directly influenced from machine learning. Like I think the original PAC paper was called something like that. And PAQ is I'll bring this up too. This is more work by Matt Mahoney, who did Data Compression Explained. And the idea here is, or this is really where context mixing comes from. Yeah, so the original paper is actually called Neural Network Data Compression. This is from the late 90s, I think. So the one that we use, the algorithm that I ended up with, I played with so much stuff, but the one I ended up with is actually very similar to what Crunchy uses as well, which is based on PAC 7. And it has several models that are mixed with a neural network. So Aaron, it's not it's hard for me to answer that question, actually, like to say it's a neural network trained on the payload, because arguably the answer is just yes. And from a certain theoretical perspective, you can just say 100% that's the case. But I would say that the way we actually put together the network feels a bit more fragmented. No, Two Curves, that's actually the interesting thing about, like, there is a lot of lossy compression that they're using that for. But actually, one of the interesting things about this kind of modeling is that when we predict bits, maybe this was hard to say because I mentioned the branch predictor thing, which does always output, for example, Boolean 0 or 1. But actually, when we predict in these models, we actually output on a continuum. And because it's a continuum, then these typical like linear networks, or these typical networks with any kind of activation function, as long as it's on some kind of continuum, will actually apply here. Now, we do everything in fixed bit or fixed precision because it's faster, a lot faster. Like even if you were to run this on a GPU, I think you'd be memory bandwidth bound for actually doing all the model predictions. And the fact that you'd be doing updates as well, I think would be pretty bad. But anyway, the models, the predictors that we actually make for the model are on a continuum from 0 to 1. And as such, any kind of like linear combination of other predictors, for example, will work. And so we do have a network that adjusts different weights for different models as they predict. And that's trained online. So they're all initialized to basically have 0 weights. And so then the output it's all on a logistic scale. And so the output basically goes from -1 to 1, I think, which is then mapped to 0 to 1, non-linearly. So initially, if your model outputs 0, basically, you're predicting that it's halfway 0, halfway 1. And then if you predict 50% 1 or 0, then when you compress a bit that is 1 or 0, it will not compress or decompress. You'll get a bit out of that. Whereas if you predict that it's going to be 75% 1 and 75% of the time it is 1, then you're actually accurately modeling and you will get compression that is proportional to how confident the model was and how correct it was. And all that's sort of described by this Shannon entropy stuff, which I hope to explain a lot better when I actually give the talk than I am now, but that's sort of the idea. So the mixer is definitely like a fairly classical neural network that's actually trained on the payload. Although it is a bit gated because you several of the edges that are in the graph, it's densely connected, but you don't use all of the edges every time. So you gate a lot of them. And I think that's very similar to how they use dropout in deep learning for better training. And we use it because it yields better compression. We can decide that some of the edges are relevant in certain contexts when we're looking at parts of the data. And that's a really effective way to train the weights better on the actual data. But before that, then what feeds into that is the output of these different predictors. But I think these different predictors kind of play the roles of neurons in the network anyway. So I think from if you squint enough, it's just a pure neural network. But at least from me working with it, I could say that it feels a little more separated than that. But that also just might be my lack of theoretical machine learning knowledge. And model mixing, and I think I want to go into squishy architecture. So I'm glad I'm actually doing this as a stream, because I can I'm glad you guys are asking questions and stuff. It's kind of helping me guide where I want this to go. I think this makes sense. We do super lightning intro, 20 seconds for 64Ks, and then just say squishy, and then we can do performance and just get that out of the way. So this is the tool we made for our intros. This is how it performs, and then we can go into how it works. So before we go into squishy, we need to look at kind of what executable compression does at a high level, and then I'll talk a little bit about how that works in squishy. But I think one of the trade-offs that you make, let's say fairly minimal, and this is a compatibility trade-off. So when you're doing a 4K, you often do a lot more header packing and crazy stuff there, where in 64K we don't so much. And that is a very deliberate choice, because whenever you do that stuff, then whenever a new version of Windows comes out, you might have to release a new version of your packer that can repack old intros to maintain compatibility and stuff like that. And that doesn't sound very fun to me as a maintainer of a packer, so I don't really want to do that. And I think what that really is a symptom of the fact that you're doing things that aren't necessarily very compatible to gain a few bytes. And the amount of bytes you gain, which is on the order of a couple hundred basically, it's not really worth having these potential compatibility issues. It's much better to have something where you could spend a few bytes to make your intro more future proof. So that makes a lot of sense to me. So we don't do so much of that. There's also import by hash, which we don't do, although that's something I might want to look into optionally doing. And again, because 64K will often import more functions than a 4K would. And so you have more of a chance that some of those are going to collide if you have bad hash import, for example, a bad hash function. So it's better to just use a more normal mechanism. We don't use the regular import mechanism because we want to compress all the function names, but we do use load library and get proc address directly. We don't do we don't walk the DLL structures and do hash import like that. And we also just we support ordinal import and those things as long as the original executable uses them. So the point is that I want the executables that come out of Squishy to be as compatible with Windows as the ones that went in. So I think that kind of makes sense. Two curbs on Windows, you don't. So what we actually do is we take the input binary and we sort of expand it. So a binary normally has a few sections in it, like code and data, and that sort of forms an image in memory. If you actually put those where they would be in memory, that's like an image, and then it might have some like zeros in between or whatever, but it doesn't really matter. So we take that whole image and then that's what we compress. And so then what we do is we put the decompressor in there and kind of move it around such that we can decompress that same image to the same location in memory at runtime. So from the executable's perspective, it's basically the same. It's not 100% the same because like the actual sections that make that up and all the headers and stuff might be a bit different, but it doesn't really matter. The executable will basically perform the same as long as it's not doing anything crazy, which again, for 64K, you're a lot less likely to do something really stupid like that. So yeah, we don't have to save to disk is the point. We just decompress into memory and then jump into the original, literally jump into the binary as if the loader would do it. So the binary just thinks it's running normally, which is kind of an illusion that we maintain as the Packer author. I'm glad you like it, Aaron. Appreciate that feedback. So yeah, we go into Squishy and then have to talk about a little bit what we do to the executables. And then, of course, the compression is sort of the main part and the part that I want to talk about most. And then that's actually a pretty deep field. So I think I'm going to spend the rest of the time talking about that. Yeah, that's exactly two curbs. We using the PE format, we request a section that's large enough that contains the original image plus the compressed stuff that we have. And then the OS loader will give us that big chunk of RAM. And then we decompress the original image into where it would be in that address space. And then we literally jump into that. In fact, the stub here shows the actual thing. So we push all the registers, clear the direction flag for string ops, I think, call the stage 2 decompressor, and then we load a function pointer that we can pass into the stage 3 decompressor. And then we do some more function things to resolve imports, and then we literally jump into the original executable. It is two curbs. You can mark a section as readable, writable, and executable. And antivirus software hates this. But you can totally do it. That's actually an option that I want to look into at some point, is to maybe dynamically allocate those sections and give them different memory protection. But it's a future thing. So yeah, you are able to do it. That's great, two curves. I want you guys to be inspired to try stupid stuff. I think that's great. Yeah, exactly. The OS is going to catch those kind of errors. At least a modern OS, which is what we're targeting. So yeah, it doesn't it doesn't really cause problems. Like, except that I think the biggest problem for like an end user, like, because if we do our job right, then and the original executable is fairly sane, then like we don't really have issues with this. However, antivirus software hates it. They see that an executable contains a single section that's readable, writable, and executable, and they're like, no, this is bad. This looks shady. And they'll also do really stupid heuristics, like they'll look at they can actually calculate at least like the first order entropy of the or zeroth order entropy of the actual section data, and if it's really high, then they're gonna say, oh, this looks compressed, that's shady. That means you're trying to hide something, and it's really annoying. Like, I've pretty much given up on that. As soon as I saw that just like our first executable tests were already being spotted as errors by a lot of antivirus stuff, then I was just like, I don't care about this. This is going to be an uphill battle where we're just going to lose all the time anyway. So yeah, I'm going to take a 2-minute break. BRB. And I'm back. Now, one of the things that when I think more about this kind of outline, I really need to like get a refresher about some of this stuff, about how this architecture actually works. Because it's been so long since I really worked heavily on this. I think most of this work was done around late 2018. By the time it got really good, of course, most of the preliminary work was done the couple years before that. And the German says, can't you do something like marking the regions as write only, and then once it's fully decompressed, change it to executable, and then jumping into it? So the issue there is, let's see. So is there like a PE Explorer tool that I can use to show the sections? There was some tool that looked really good for this that I was going to check out, but... yeah, never mind. But Yeah, that is what a lot of JIT compilers do. So the issue is that when we compress the executable, a normal executable has like a code section, data section, a BSS section, and whatever else. And what we do to reduce the amount of Windows headers that we have to store in the executable in order to save space, we actually merge all the sections into one section that then we make readable, writable, executable. And one thing that you could do is you could make that, for example, readable and executable. So there would just be a single section. And then you could import functions to change the memory protection there. And I guess you could, yeah, you'd still, to reduce headers, you'd only want one section, so you'd have to do that. And then you actually wouldn't have anywhere to put any data that you could actually modify. I think you get stack space already allocated from the OS, but I think that's it. So I think with just stack, you could probably be able to import enough libraries to get to the memory protect functions. And then maybe you could change it at runtime. Maybe that helps compatibility. And then I think that only hurts because you have the extra code, which has to be uncompressed because you can't, unless you decompress onto the stack, which I think would be ridiculous. So it's probably possible, but it's a bit different because the problem we're trying to get around is not the memory at runtime, which is normally what we would do, but it's the memory. It's the executable file at, like, once it's actually finally produced that the AV antivirus stuff is actually looking at. So yeah, it might be possible, but I don't think AV scanners are gonna. My gut feeling is it wouldn't help. But yeah, I mean, that is normally what you do, is you normally allocate some memory and then allocate some aligned memory and then actually change the memory protection for those and do some kind of JIT there. And in fact, that is what the JIT in the demo does. But that's, of course, after it's been decompressed into this single section, which has been made smaller, or where the executable has been made smaller because we only store metadata for that one section. I don't exactly remember. Yeah, the section header is not terribly large, but it's still, you don't want to have multiple ones of these. I think too, an antivirus piece of software is probably gonna freak out if you import memprotect or something. I know some of them will even start executing some of these executables like in a sandbox, and we'll probably catch some of those kind of things. So my gut feeling is that this is just not really a battle that's even worth fighting at this point. But there may be ways around that. But at least the way it is now, we don't worry about it. We just grab one section and then do everything in there. I'm actually kind of tempted to just like write this license and maybe I just release this now. Because I don't really want to wait. And I think it'd be nice to have this this stuff released as soon as possible. I can just show some of this because it doesn't really matter. I'm going to turn on some music if I'm going to actually write some code. Just for me, though. Because, yeah, I wanted to have this released like ASAP. And I think the only thing was the licensing that I had left. Exactly, bye for C. So yeah, I wanted to download Crinkler actually. And by the way, I actually should share this. This is funny because if you actually go to logicoma.io/squishy, this page has been there for like a year. But it doesn't really have anything here. You can see like comparisons. There's just some Fresh Prince of Bel-Air lyrics. But this is where it's going to be. This is where I'm going to actually have the landing page. And I'll totally have like a change log and everything too. In fact, I think I already in the Squishy repo added. Actually, maybe I should pull up how recent this is. Okay, so I was even working on that. So this is pretty recent. That's not a fix I'm going to do for now. I even have a README because I think it was in like late last year. I started figuring out how I was going to package everything, and then I got stuck on the licensing and then got distracted. So yeah, here, 6/10/2019 is where I actually built the pre-release version, where I was thinking about releasing it then. But I think I'm going to rebuild this pre-release version and just say it's released now because I didn't really add any features anyway, so I think that makes sense. Then I can pack it up with a proper license. So I also wrote scripts and everything for me to actually package releases, which is nice. But yeah, the reason I wanted to download Crinkler, which I have to download because I haven't made a 64K or 4K in years, that wasn't for C64, is to look at the license. And I had some notes here again to look at this. Yeah, I think the code itself is gonna be under MIT Apache 2. So that's Squishy itself. Except I actually think that was what I was thinking, but I think I would go, yeah, more I think about it. I like having a custom license based on Crinkler. It distributes it under itself under this, and output under certain conditions. I guess I should also update like the copyright year and stuff. I think we have no actual changes. There's a lot of messy stuff here, which I don't want to erase. Some of these outputs things are really funny. These are huge files, and these I would run some genetic algorithms to try and tune some of the parameters for the compressor, especially when I was playing with an architecture that would actually have different model architectures encoded in the executable. And I found that wasn't a very good idea. But yeah, this is going to be 2020 now. That's when I'm actually going to release this. And if I release this today, I might as well just pack this up now. So what is it, 29th of March? Yeah, it says pre-release. But I think I'll do, yeah, initial. So I think I want license here. I think. Yeah, so everything in this package stir will be included, so that's good. If I make a license file in here, then we should be good. Yeah, I think also you need to have a proper name on this kind of thing, so let's do that. And maybe I should actually update the text in the actual thing. Yeah, then this is updated. Yeah, so when you run squishy, you see this big squish and the small squish. And the big squish is this what I call the stage 2, because it's packed in like the reversed order. So this is the stage 2 compression. Again, that's the main part. And then the stage 1 compression is like, yeah, 2.3 to 1.7K. So much lower compression ratio, but still totally pays off, because this is like, I mean, do the math, 500 byte savings or something just doing that. Yeah, so I actually don't think that I can release this with like MIT Apache 2 and still have these additional clauses. They deal in the software without restriction, including rights to use, copy, modify, merge, whatever, as long as this stuff is here. And then basically the only thing in the MIT licenses is this liability clause. So that's kind of the idea here, is that you grant basically all rights as long as they must include this license, which again is to be able to make sure that this liability clause is always there, present with the software. And if not, well, then you say, well, you broke the license of my software. You violated that by distributing this with this, and then that's not my problem. But yeah, this here is totally just like a liability clause, and that's the MIT license. And I need more restrictions than this. So I think we'll copy some of this text. Again, I am not a lawyer, but we're going to do our best here. Do some line breaks. We already have copyright listed there. The actual copyright text is not copyrighted. Good to know. Or do you mean this? I don't know what you mean. Just gonna modify some of this stuff. I'm just gonna start removing some of this. I don't want it to sell stuff. I like that they list a lot of these. You know, I might as well. Well, no, I do. I think this is okay. I think it's okay if people modify this stuff too. I do want to have that and to distribute and publish it. I'm okay with that, as long as all of these are intact. At least that's what I'm trying to describe here. I mean, this is about as good as I can do, right? Crunchy's actually in the public domain, which is kind of funny. But I'm not really worried about like liability for this kind of thing. I'm worried enough to write the license and to kind of like do a best effort thing there, but beyond that, this is what I can do, I guess. Okay, well then that would be a license. At least as good as I can do. Then what I want to do is take CD releases, because there's already a Squishy 010 release there. And I think, yeah, it gets, is it -D? Yeah, it is. I think that'll delete it on the remote. I just want to make sure, I don't remember. Well, I mean, I have this README here that I can read to give me what I do here. Make sure those changes are merged to master and that they work. These are only documentation changes. Ooh, that's not good. It's not good at all that I ended up with the wrong line endings. I thought I had all this stuff set up. Yeah, that's the correct default. So then is it Control-Shift-P convert indentation? No, that's not it. Change end of line sequence. LF. There we go. Okay, yeah, so it was actually encoded that way before. That's my bad. Well, now it's a good time to change that then. Oh, that's where it is. That's funny. Yeah. I think I need to also add. I think that's what I wanted. Yeah, I do have this on Spaces, and that is what I want. I want it on Spaces. I don't know if you guys have watched that HBO show Devs. It's weird. But we watched about one episode, and there's this whole scene where the first time the dude looks at the code at like the dev's office, he just like freaks out and runs in the bathroom vomiting. And I looked over at my wife and I said, yeah, he must have seen tabs in the code. I thought that was pretty funny. But yeah, I think I can run pack release 0.1.0 now. And I hope this works. This will take a bit. Yeah, I don't feel that strongly about it, but I prefer Spaces. That's about it. Yeah, so what this release script will do is it's going to build x86 and x64 versions and then pack up the archive and everything. Yeah, it also looks like it will add a pack commit and do the tag and everything, which is nice. There's no like dry run of this, which is kind of annoying, but that should be fine. But my particular machine has a lot of different Rust toolchains on it, so this, I guess it will update all those. It's a bit of a heavy hammer, but it's useful. No, I don't pack the packer with the packer. And the reason for that is because I don't want to sit there waiting for it to decompress every time I want to compress an intro. So Compression. Yeah, one thing that I didn't talk about at all with this outline is that there's quite a lot of engineering that went toward compressing x86 well. And that's one of the more interesting parts of the compressor. Also match models, which are interesting stuff. So for like larger contexts. And Squishy actually does some pretty crazy stuff here. Crunchy actually does this by taking all the x86 code and like running a sort of rough disassembler on it and reordering all the bytes such that they all go into like different streams. And then he runs the normal compressor on top of that. Whereas Squishy kind of does it the other way, where we leave it in place, but as part of the model, we run that rough disassembler instead of a post filter that kind of puts it all back in order. We leave it in place and we let the normal models still operate on that in place in case there's like some correlations within that original representation that we wouldn't capture otherwise. And then it also runs that disassembler like as it scans through the code section. And it runs a whole other set of models with different like mixer contexts and stuff based on the state of that disassembler. So it's kind of like the idea is I want to capture both correlations that we force by doing reordering, but also ones that we might have missed by doing that reordering. It seems to be pretty effective. But I actually think the call and jump address transformations that Crunchy's able to do are a bit better. Although every time I've tried to implement those within this framework, they seem to do worse. So I don't really know what the deal is there, but I think it needs more experimentation. That's fine about Rust format. I don't care about that. So now it's building now I get to the actual interesting stuff. So it updated all my tool chains, and now it's building for x86. And we use the GNU builds for this, now x64 as well. We use the GNU builds for the releases because they're statically linked, so they have everything. But I added some stuff in the manifest. For example, link time optimization. And this will allow it to strip away a lot of that stuff. So yes, the presentation is going to be streamed on the Twitch channel. That's important. So that was it. It's now packed in this release directory. So you can see releases squishy 010. There's the license we just wrote. There's the README. There's the two builds, and then there's the zip file, which contains all of that. So that's pretty cool. I'm going to test these. I think that would be a good idea. So if I go to Ferris, dev, projects, lots of stuff, squishy. Releases this one, and I'll even pull it into a different directory. You can see each of the executables like 1.5 megs, but that's fine. That's fine by me. Just stick it in downloads, I guess. As if I had downloaded it. Just extract it here. And if I open a new terminal there, let's see. So we can do run the x86 one, and then we could do dev project squishy corpus. Let's do demo scene, logicoma. Let's do trash panda. Actually, we'll do iota because I've just been watching that a lot lately. Oh, I don't even have iota added here. Oh, that's stupid. Let's do trash panda. So now it's building. And again, these x86 and x64 builds, these are builds of the Packer itself. The Packer doesn't support 64-bit executables. Maybe it will in the future. Probably not. So we'll go ahead and run this. I double clicked it, and now we're waiting for decompression. And now it happened. We can just run this to be sure, but of course it probably works. We'll watch the whole thing just in case, and I'll re-enable my sound. Does the compressor get the demo size to the Kolmogorov complexity of the final video? We'll never know. If you can find a way to calculate it. The optimal Kolmogorov complexity, then a lot of people would be very happy to know how you did it. I like this demo. I mean, I'm supposed to, but I do. Commented out, which is why there was a lot of warnings, so I haven't like properly added arguments for that. I figured that stuff's easy to add. Once you get the initial release out, it's easier to do subsequent ones. So this is kind of the big leap. Like technically it's not any harder to do that stuff now or later, but practically it kind of is. So now I'll test the x64 build. I'll actually do it with a different intro, which is not like an apples to apples comparison, but I think that that's fine. So for this one, we can do Engage, for example. Something I haven't watched in real time in quite a while, actually. That appears to have worked. And again, that little waiting time there is the decompressor time. And if it was much longer than that, it would be bad. So we could actually get better compression if we, for example, had a loading bar for that, but I think that that's a bad experience to wait for like 30 seconds to decompress on top of waiting for the normal loading stuff. It looks like on OBS this has a really bad frame rate, but I don't know if that's the OBS preview or what, because it's running very smoothly on the actual machine. I don't expect there to be any bugs, but I'll still watch the intro the whole way through just in case. I don't know why it's a bit laggy. but it's not for me. Maybe the encoder's hiccuping or something. It's rendering real time Lucid Frost. Doesn't look like it's that real time on the stream, apparently, but looks solid for me at least. I don't know if I mentioned this, it's a bit off topic, but next week, by the way, we'll be back on more tooling work. It's just that since I have this deadline to get in the recording and information for the talk, I'm doing some of that this weekend instead. The deadline is next Saturday, so like, I'll be done with it then. Is it just me, or did it get smoother on the stream? At least on OBS it looked like it did. No idea why. Like it was the same the whole way through for me, but whatever. Well, okay, so this worked. That's the important part. Then I might as well start putting this up. You guys are witnessing history. As F. Let's see. Tacoma www. That's what I'm looking for here. So this is totally static. Isn't it? Oh, I haven't pulled this repo on this machine probably. That's why. Exactly 2 curves. You know, I did actually just remember that there's a logo that's supposed to go with this too. But I think I'll just make that part of the web page later. At least now we can sort of get this out. I'm going to close this, by the way. Like you knew me. Thanks for the follow. Oh, that could be Love Like Semtex. Could definitely be. I feel like I've had good luck, but I actually updated OBS last night for the first time in like 3 years. I was always afraid I'd lose my settings, so I never did it, but finally just bit the bullet. And maybe that made it worse, or maybe it just is hitting me now. Who knows? Yeah, this landing page is what I was doing. Should include the logo done by WS. I'm actually going to dig that up. Maybe it's easy to incorporate now that I'm going to make these changes. This is the logo, quite large here. Something like that. I thought that we had a colorized version, but maybe not. Oh yeah, I was going to do the colored version. That's what it was. I feel bad for not getting back to him sooner. I need to contact him. So yeah, I'll do the logo later. Just to make sure I have everything I need. And then what do we want to do? We want to have, yeah, so now static should have this squishy page. Should probably also actually do something with this landing page. I think that's fine. But the nice part about having this static is I can just look at it locally. Which is not like that, but like this. Yeah, this is the local one. Oh, really? It didn't get the assets like that? How? Oh, apparently this is linked differently. I guess I need to run the site locally. That I can do. Let's see. There we go. So localhost 3000. There we go. If I do /squishy, there we go. That's the local one. So then we might as well start doing releases. So I'll make the releases directory, and then I'll go ahead and move the packed file there. And since I already basically wrote this stuff, I can do here. And I'll just do really basic stuff here. So we'll get the link here. Do I just want that? That's probably fine. Look at me with no CMS. Oh, I don't have formatting for links. That's great. We can just do the same as some of these. Do, for example, this on A, and then we'll do just these same things. What is it? Font decoration is underlined. Or text decoration, that's what it is. Is that not it? Oh, it's not A, is it? It's that A. Like that. I think we don't want the padding. I think just seeing that written out will do. We'll do this. Do I actually want to do this as like a list item? Probably not. I think we can do this too. Also, I was thinking about changing the font, even though I quite like this. We'll see. And then I wanted to have this information here. In fact, actually, why don't I do this exactly? That's probably what I actually want. I can do this. Why have all this fancy stuff when this will do just fine? Oh, and I just realized I have a typo here. And that's totally fine by me. I don't care. I don't want to pack a new release for that. Yeah, that's a good point, Aaron. I think I should maybe be above that even. Actually, let's do this even. Let's put latest release up here. And then we can do previous releases later. That's probably a good idea. I think I'm going to turn these into links while I'm at it. I hope these groups don't mind that I added them here. Probably not. I can just add poet links for these groups. This is kind of a pain in the ass, but I think it's worth it. So I wrote and more because I know these groups used it, but I also know that there have been other smaller productions where this has been used. And that I know of, and there might even be ones that I don't know of. So if you guys use this, let me know. And I'd be happy to put it here. I am extremely proud, actually, after seeing the Meteorix nominations, that of the 5 64K nominations, 3 of them used this packer. Oh, did I not do the quad trip one right? I'll fix that. Oh, that's what happened. You can see, let's come on mode, add Macau exports, polarity, quad trip, Ivory Labs. Great. But yeah, they use this packer and our synth, which is really cool. So even though we definitely released less as a group last year, I don't really feel like we had less important contributions, so I'm pretty proud of that. Now in terms of contributions, I mean not contributions, take comparisons. Just to stylize this. No, that didn't look very good. You know, what I think we can do is, instead of doing like historic releases, let's do latest release. And then down here we can do release notes. Or even just releases, which I think is what I have here. Oh, the changelog even is what I call that. Then I'll do that. Changelog. And then we can just do this, for example. Maybe even this is what we want to do. Just see how that looks. No, I liked it better the other way. And I kind of actually liked having this additional information there too. So let's do that for the latest release. And I think that's good. I don't mind that this is duplicated because this will be expanded later. And that works here at least. Let's see if it actually works when we publish it. Test this link as well. Looks good. And then eventually I'll add links for like blog posts and stuff about this later. And of course the talk that I'll give in a couple weeks. But then I might as well just push the button, right? I think... Oh yeah, gotta update the copyright here. 2020 now. I don't think we need the word download, right? Click this and you have it. That's it. I think this is okay. For panic reasons, yeah. That probably is actually a good idea, right? Yeah, I like it better with that. We'll try it, but I think this is okay. It's at the top enough. If we look at, for example, Crinkler, you know, it's not very far. I think we're good here too. Oh, that's the public page. This is not. Then I think I want to push this. Then I have to remember how to actually update the website. Which I think... Okay, I'm in. And I think I just need to do a couple things in GitHub and magically stuff happens. That's the idea. Since it's all static, I think this will just work. And it does. So there's our links updated. And there's Squishy. Holy shit. Oh, I just got nervous. For no reason. I guess now I spread links, right? Dump it in the demo scene Discord. Yeah, thanks Aaron for putting that there. I might also do some changes to the landing page on Logicoma.io, which right now just has this and has for several years. So at least a link to this page would be nice, I guess. guess I should make a poet entry now, shouldn't I? Let's do that. That's actually something I feel like I haven't done in years because people keep doing that before I'm ready. Which I guess I can't complain about. The demo scene has been very good to us the last few years. Download Earl. So we can just take this one for now. This is going to be Windows. Type is a tool. No party. No DemoZoo ID. We can do an info file. We can have the latest README. Last time I did it was Bros Before Foes, it looks like. Thanks, Yana Moran. I'm kind of excited about it now. Let's see. Noted. I gotta stop streaming soon. But I'll finish this up pretty quick here. That looks great. That's very cool. My wife dyed her hair purple while I was streaming. I want to just set up a little screenshot that's just like a terminal window. Or at least part of it. And so I need to set up... yeah, enough stuff there. And I think I want to make it match this. Uncompressed and then compo winner. I think that's cool. Oh wow, yeah, it's been 3 hours since I started streaming today. Whoops. Let's do Elysian. There's something. We'll call that uncompressed.exe. So I think we do uncompressed like this. And away we go. We use the good old snip tool. And I think something like that, which is probably too wide. And then if I think I need to scale that down, not photos, Photoshop. I think if you do create new with an image on the thing, yeah, you get the clipboard. So that's great. That's this. And then we need to scale this down because I think this still has 400 by 300 pixels. So we need to do image size and do that down to 400. Maintain aspect. We'll do automatic resample, which is fine. This looks good enough to me. And I think if we do this as PNG, it should probably just be small enough, but we'll see. Yeah, 28K, so we're good there. If we hit submit, I think we're done. And then I want to also add some additional links here. I'm thinking, actually, did I add a link to this web page here? I probably should do that in the README for, oh, I do actually have that here. I'll just double check that that's the right one. And it is, so that's good. Then I'm happy. I can add a credit too. It's me. Code. Thank you. I'm gelling for the follow. But yeah, cool. Well, I gotta go. This was fun, and I'm glad to have your guys' input as well in outlining this talk. So I got a couple more things to do today, like send them a picture and like a synopsis of this. But I think I'm pretty happy with this kind of outline, and I think I can make a good short blurb from this. So I think I'm prepared enough for today. So yeah, this was really fruitful. And now Squishy's released. That's pretty cool. Nice. All right. Yeah. Thanks guys for hanging out, and I'll see you next time. Yeah, I'll save the file. No worries. Thanks. All right. See you guys.